Welcome to the Mission to Mars, a program presented on behalf of the Ismaili Jamatkhana and Center's virtual series. My name is Banush, and I serve in a voluntary capacity as the Member for Communications and Outreach on the Ismaili Council for the Southeastern United States. The Ismaili Jamatkhana around the world are more than places of worship and spiritual search. These spaces hope to encourage community engagement and broaden our intellectual horizons. From the beginnings of Islam, the search for knowledge was encouraged. In the words of Hazrat Ali, who is the first hereditary imam of the Shia Muslims, no honor is like knowledge. We can search for knowledge by first admitting what it is that we don't know, and then by opening our minds to what it is others can teach us. Astronomy has played a significant role in Muslim civilizations. For example, the moon captivates cultures. Modern-day scientists can continue to contribute significantly to the knowledge society. Recently, to celebrate the 50th anniversary of one of humanity's greatest accomplishments, the first lunar landing of man on moon, the Aga Khan Museum in Toronto launched a major exhibition titled The Moon, A Voyage Through Time. The Mars 2020 mission with its Perseverance rover is part of NASA's Mars exploration program, an effort of robotic exploration on the red planet. The mission addresses high priority science goals, including key questions about the potential for life on Mars. We are honored to have with us today two key experts that are part of this mission, Dr. Philip Twu and Dr. Mohamed Abid. At this time, I'd like to introduce you to the moderator for this program, Ali Thalaksi. Ali is currently pursuing his master's in aerospace engineering at the Georgia Institute of Technology. Welcome, Ali.
Thank you, Banush. I'm honored to introduce to you Dr. Philip Twu and Dr. Mohamed Abid, the engineers behind the Mars 2020 mission. Dr. Mohamed Abid is the Mars 2020 Deputy Chief Mechanical Engineer and Manager of the Mechatronics Group at JPL. He is a lecturer in the Astronautics Department at the University of Southern California and the author of the textbook Spacecraft Sensors. Dr. Abid holds a PhD in Aerospace and Mechanical Engineering from USC. Dr. Philip Twu is a Robotic Systems Engineer who earned a PhD in Electrical and Computer Engineering from the Georgia Institute of Technology. Since joining JPL in 2017, he has had essential roles in both technology development and flight projects. His contributions span from designing and evaluating autonomous algorithms for coordinating unmanned vehicle swarms to being the systems engineer for rover navigation on the Mars 2020 mission. Welcome, and thank you guys for joining our virtual programming series.
Thank you for having me. It's good to be here.
I'm here. Thank you.
Great, really great to have you guys. I want to begin by asking you guys, would you guys please be able to explain to our listeners what the Mars 2020 mission is, what are objectives, and why is the destination Mars?
Okay, sure. I can actually get started on that. So you could please go ahead and pull up slide number 1 here. So the Mars 2020 mission is actually going to be the 5th rover that NASA is going to be sending to explore Mars in over the past 2 decades. If you look at the picture here, this actually gives you a brief history of the rovers that NASA has sent before. You start with Sojourner on the bottom left here, landed in 1997. This was the first ever Mars rover, and it went to Mars to study what the Martian rocks and dirt was made out of. And then you have Spirit and Opportunity on the top left here, landed in 2004, and it went to go and answer the question of, okay, did Mars ever have water in the past? And if so, was there enough water to have ever supported life? Okay, and it discovered that both of those answers were yes. And then you have Curiosity on the right here, landed in 2012, and Curiosity went to then ask the follow-on question, which is, now we know that ancient Mars had water. Did ancient Mars also have the additional chemicals, the right chemistry to support microbial life? And the evidence suggests that yes, ancient Mars did have the right chemistry. So that leads us to Perseverance rover, which is the next step in this investigation, where we are actually going to go and directly look for evidence of past life on Mars. So if you go to slide 2, please. So on July 30th, 2020, the Mars 2020 mission is actually going to be launching from Cape Canaveral, Florida. It's going to travel for about 6 months before landing on Mars on February 18th, 2021. And the overall design of the spacecraft and rover is going to be based off of the Curiosity mission from back in 2011, 2012. But because we have new objectives this time around, we also have a lot of new systems and a lot of new upgrades to the rover, including new wheels, new sensors, a brand new navigation system, and even the Ingenuity helicopter that's going to be carrying on board. So if you go to slide 3, please. Now, as far as Mars goes, where we're going this time is a place called Jezreel Crater. If you look at the picture on the top, this actually shows you all the places that NASA missions have landed on Mars, and the yellow star in the middle right is where we're going to be landing this time around. Now, what makes Jezreel Crater special is that scientists believe it was actually once home to an ancient river delta that had both the long-term water and key chemical ingredients needed to support life. So if you want to go and look for evidence of past life, this is the best place to go. And with that, I'm going to hand it over to Dr. Abid to talk about the science objectives.
Thank you. So with regard to the objective, there are mainly 4 overarching objectives for Perseverance, in a way, kind of continuation of what we learned before and answering different questions. One of the objectives that we have in place is, understanding a little bit of the geology of geological history of Mars, and more specifically for where we're going to be landing, Jezreel Crater. And with that is, look at the various layers of the rock composition and get some history on the planet, in its distant past. So that's one of the goals. The second goal is what we call to answer some questions for astrobiology. In essence, what we try to do is search for past microbial life. Is there any microbial life in the past? And any evidence actually of its presence? We're not necessarily going to find a specific creature or so, but it's more like is there any signature on those that could have spanned throughout billions of years in the past? And these are signatures that are embedded in various rocks. So the third objective is the sample caching system, and what it is really, in essence, a way to be able to start the chain of bringing samples back to Earth. As you know, on Earth we have plenty of resources with regard to investigation, a lot of laboratory to perform analysis and diagnosis and whatnot. In order to do that, while Perseverance has a very high technological instruments that will do some in situ diagnostics, but it's not enough to get the full extent of it. So what we're going to be doing is we're going to be able to collect some samples of rocks from Mars and prepare them for the next mission that will be coming down a few years later, where they're going to come and collect these sample tubes, bring them back to Earth for further study. And then the last main objective is preparation for humans. And at the end of the day, we would like to send human to Mars for various reasons. But in order to do that, one of the constituent is, for instance, understanding a little bit about being able to produce oxygen. As you know, oxygen is used for breathing. It could be used also as an oxidizer for rocket and whatnot. But in preparation for things like that, we need to have technology or embed some technology that help us for future humans and Mars. So one of the demo that we're going to have, what it is on Perseverance, is the MOXIE instrument that will generate oxygen. Yep.
Okay. And I could actually speak a little bit to as to why we're going to Mars, right, as opposed to anywhere else here.
Right.
The reason why we're going to Mars this time around is, and why there's so much focus on Mars, is because, well, for one thing, besides the moon, Mars is really the next most accessible place in the solar system to humans. Okay, you look at all the alternatives here. Venus, right? The surface of Venus is way too hot for humans to go visit, and it's also way too hot for a lot of our electronics and our robots. And then you look at the other alternative, which is Jupiter. Jupiter is too far away. It takes a long time to get there, and it's a gas giant, meaning it's not a solid. There's no solid ground like on Earth. If you try to step out of your spacecraft and walk on Jupiter, you're going to sink right through because it's all gas. So that's why it's really the most logical place for humans to go and try to explore. And the other thing is Mars is also a lot like Earth in a lot of ways, right? The current research suggests that ancient Mars had an atmosphere, had warm temperatures, and it had an ocean on the surface, very much like Earth today. But when you look at Mars right now, it's not like that at all, right? So the question is also, okay, what happened to Mars? Why is it so different now than it was in the past? And also, because ancient Mars was much like Earth in so many ways, it's also the best place for us to look for life in the solar system based on the way that we currently define life. Looking for life as we know it. So that's why we're going to Mars.
Great, thank you guys very much for that response. I want to ask a question, Dr. Abid. Would you be able to explain to our listeners how rock samples and what type of rock samples are going to be collected and analyzed on Mars?
Yes, absolutely. If you can get the first chart, just to help you put things in context. This is a really cool, complex process. It is part of what we call the SCS, the Sample Caching System. This is the most complex robotic system that we ever built. And what I'm going to describe here is not going to give justice to all the engineering that went through and all the testing and all that stuff, but at least it gives you an overview about how it's done just in general. So first thing is we got to choose this rock that we're going to drill into it, okay? So scientists will gather, will figure out based on the layout of the ground, based on where Perseverance is at the moment, and pick the rock that will make the most sense, that has the highest likelihood of getting some meaningful science. And so once that's done, then we're going to select a tube. We're going to be carrying 43 tubes. These are a small tube about this size. They are the cleanest sterile tube you can find on Earth. And so what we're going to do is, these are titanium tube. We're going to insert them in a drill bit. As you know, drill bits, as you typically use, it's not really the classic drill bit that you use at home. It's something that, fairly large drill bit that has a hollow. It's a hollow drill bit, and we're going to insert a tube in it. And so then we're going to ask, this long robotic arm, it's about 7 foot long robotic arm. We're going to place this tube inside at the tip of it, and then we're going to go to the rock of interest, okay, the one that was picked by scientists. We're going to position this drill, stabilize it, and core. And as we core, we're going to go a few inches down. After a certain distance, we're going to decide, okay, well, this is sufficient core we collected. I'm going to bring back that robotic arm into Perseverance, okay? It's going to interface with what we call a bit carousel. So the bit carousel is like a spinning wheel, okay? And it has multiple drill bits and multiple ways of transferring the drill bit from the robotic arm into the inside of Perseverance. So once it's in there, we're going to go through a slew of activities. We need to extract the tube back from the drill bit, okay? Then we're going to measure how much dirt do we have in there. We're going to take a selfie. It's very important to take selfies. And then what we're going to do, then we're going to store it, and we're going to hermetically seal it, okay? That way we can maintain the core that was extracted from the rock. The size of the core is about a chalk, probably chalk. We don't use chalks these days for teaching, but it's about ½ inch to about an inch or two long a sample. So then once it's hermetically sealed, at a certain point during the mission, we're going to drop these tubes on the surface of Mars. And this is the part where we leave it there for a little while. And a few years later, this is where it gets also even more interesting, is we're going to have another mission called Mars Sample Return. And what's going to happen there, we're going to get another rover. They're going to come and fetch rover, going to come and collect all these tubes, and then put them into a rocket, okay? And then that rocket will launch from the surface of Mars. And this is the whole idea of bringing the samples that we collected from Mars to Earth. and rendezvous with another spaceship that's going to bring it to Earth for further study and analysis. Now, it sounds probably a little simple, maybe, but it's really complex. And in order to get to this point, we went through a lot of engineering, design, and testing, and that led us to where we are. As you probably know, the space is a very challenging environment. We have to fit everything. All what I described has to fit within Perseverance, and so they're a lot challenging to fit everything in that box. The other thing is that is very unique for Perseverance compared to the prior missions, is that since we are looking for biosignature, what we did is that we got to make sure that these tubes are extremely pristine, clean. In another word, we don't want to take any spores, any dormant bacteria with us. That's why when we bring it back on Earth, we're not going to confuse. We think, oh yeah, this bacteria came from Mars, but actually it's actually from Earth. So we have to be very careful. We were very careful on how we made these tubes, make sure that they are contamination free. And so the chart that I didn't really speak explicitly, but shows you a little bit the various steps that I was describing on how pick up and choose and return. So that's in a nutshell what went into it.
I can promise you that does not sound simple at all. Thank you very much for sharing that with us. Dr. Twu, I know that you worked on the very complex auto navigation system, which is some of the most advanced technology that we ever sent to Mars. Would you be able to explain to our audience how the rover is going to be able to navigate itself on the Martian surface?
Yeah, of course. Okay, could you pull up slide 4, please? So before we talk about how the rover drives around, I just want to make sure everyone has a mental picture of, okay, what is it even like on the surface of Mars? What does this rover have to navigate around, right? So these are just a couple of example pictures of the type of terrain that we see on Mars. So in terms of navigation on Mars, really excited about the Perseverance rover, because this time around, the rover is going to behave a lot like a self-driving car. Okay, so the idea here is that every single day, mission control on Earth is going to send a satellite signal telling the rover where it needs to go, and it's going to be up to the rover to just figure out on its own how to get there. Okay, now the biggest difference between a rover and a self-driving car back on Earth is that the terrain is very, very different, right? I mean, self-driving car on Earth has to drive on roads, and there's traffic rules, and has to avoid other cars. Whereas on Mars, our rover has to navigate in terrain like what you see in the pictures here. There's rocks, large rocks, small rocks, there's uneven terrain, there's different types of terrain, there's slopes and hills and sand and everything. So it's very similar to a self-driving car, but in a sense it's also looking at a slightly different type of problem than a self-driving car is here on Earth. Now, the way this all works is that, first of all, the rover uses high-resolution cameras to take a picture of its surroundings and create essentially a 3D picture to understand, okay, what is around the rover? Okay. Then the rover uses brand new navigation software that we developed for this mission to look at the 3D picture and identify any dangerous areas around the rover that it doesn't want to get near, things such as rocks or cliffs or other things that the rover might want to stay away from. The rover then goes ahead and considers different paths to drive. Right? What if I drive this way to the left? What if I drive straight? What if I drive to the right? All these different paths that it considers, and it uses a lot of computations, math and physics underneath the hood to try and compute, okay, what is the worst that could happen if I were to drive this way versus that way? And it compares all these different options that it has. And from there, the software then goes ahead and chooses the best option for it to safely drive towards its destination. And this process repeats over and over and over again, and for the rover to eventually get where it needs to go. Now, the overall concept that I described, it's conceptually quite simple, and kind of similar to what we do as people. But the challenge here is, how do you do this fast enough? Right. In order to accomplish this mission, our Perseverance rover actually has to navigate many times faster than any rover before it ever has. Now, the problem here, what makes it challenging, is the radiation on Mars. All right, so if you bring a normal computer on Mars, the amount of radiation that it encounters is going to essentially cause it to crash, and it's going to cause the computation to have errors and so on. And we don't want that to happen to our rovers. Right, so to work around this, our rover actually has a special computer on board that's essentially immune to the radiation. But the problem is, in order to make these computers immune to the radiation, it's a lot slower than what we're used to back on Earth. So to put things into perspective, the computer on Perseverance is only about as fast as a typical desktop PC from 1997. Right? That's about 23 years ago, or about 10 times slower than like the typical smartphone that we all carry in our pockets every day. So that just goes to show what we're working with here. Now, due to this limitation, right, the old rovers, the rovers in the past, what they would do is they would drive. And then because these computers were so slow, they could only compute so much, they would drive for a little bit, and then it'll stop for a couple minutes to think and to process all the data and analyze all the data. And then it'll drive a little bit again, and then it'll stop for a couple more minutes, and it'll just keep stopping and going and stopping and going. Now you can imagine this makes the navigation really slow, right? Can you imagine if your self-driving car on Earth did something like that? It would drive you insane. So for Perseverance, to work around this, what we did is we actually added a second computer that specializes in a lot of the very difficult and time-consuming computations, especially built to do those computations as fast as it can. And because of this, we have two computers working in parallel, and that allows a rover to actually drive and think at the same time. And it lets us drive much faster than any rover before it ever has.
That sounds great. Thank you so much, Dr. Twu. Dr. Abid, can you give us some background on MOXIE? I know you previously mentioned that a little earlier. And how could this possibly help future astronauts when they go to Mars?
Absolutely. The atmosphere of Mars is composed of predominantly by CO2. 96% of the composition of Mars atmosphere is CO2. So, in order to be able to for astronauts to breathe, for future, this is kind of preparation for future mission, is you need to have some oxygen in one way or another. So there's a couple options. So you can haul out all the oxygen with you from Earth, okay, or make it in there, or have some mean to be able to make your own oxygen on the surface of Mars. And the idea is that can you take CO2, carbon dioxide, and out of it extract oxygen. Okay, so this will help us kind of in an in situ fashion. So for that, we have this tech demo that's called MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment. And what it does, basically, it's a demonstration instrument to show that we actually can take CO2 and extracts oxygen out of the CO2 for breathing. It could be also used for as an oxidizer for rockets that we might use in the future for return and things like that. So if you want to pull this, yeah, okay, so you have the chart, perfect. So if you look at the chart here, what you have multiple instruments on the top left pictures, and that's where resides the MOXIE in the front of the rover. The picture to the right, it shows you the open open stomach of the Perseverance. So when you open Perseverance at the top, that's what you see. You see an ocean of cables and boxes and things like that. And MOXIE, that's where it's residing. So in an essence, what it is, so basically, this is a box that's as big as a battery car, roughly about 36 pounds or so. And what it does, it's basically, it takes in, using a scroll pump, pressurized CO2, carbon dioxide, and then what it does, it is fed in what we call a solid oxide electrolysis. This is kind of a SOXY. It's an inverted fuel cell, and it is heated at about 800 degrees C. So with this process, we electrochemically split the CO2, the carbon dioxide at the cathode, and we produce oxygen at the anode. And this is, if you're familiar with fuel cell, it's you invert that process, and this is what you get a little bit in here. So for the chemist, Abid, it's a 2 molecule of carbon dioxide will get you 2 molecule of carbon monoxide and some oxygen. So with this process, we're going to be producing for the first time oxygen on Mars, and we're hoping to get something like 10 grams or so of oxygen per hour. Someone may ask, well, how does it relate to human? Well, on a rest, in a rest day, in a rest hour, I mean, typically we consume about 30, 40 grams of oxygen, something like that. So it's scalable. And so the idea is that with that, we'll be able to show that, yeah, verily we can produce oxygen on Mars. We can rely on something similar to this. And, a scenario could be, send the whole infrastructure of, this kind of production for oxygen. And when astronauts shows up at a given time, they will have sufficient oxygen to breathe, sufficient oxygen to use for rocket as an oxidizer, and so on and so forth. So very excited about this experiment and looking forward to make oxygen on Mars. So.
That's great how this rover is already laying the seeds for putting astronauts on Mars. I think that's fantastic. Kind of a question for both of you guys. What's the mood of the Mars 2020 team right before launch? Is it one more of nervousness or excitement, or a mix of both?
You go.
Yeah, I can go ahead and start. Personally, I'm a lot more excited than anything else. There's definitely a tiny bit of nervousness, but I think excitement is definitely more overwhelming. Personally, I've been working on this mission for 3 years, but I know other people on the mission who have been working on it for like up to 8 years or so. So, people have put a lot of time and energy into this project, and I think at this point we've all done our best to make sure that this mission is going to be a success. So once you've done everything you can, all you can do is just trust in your work and let it happen. So personally, I am ready to begin exploring Mars.
Yeah, I know it's the team is ecstatic. I mean, super excited. This is really, like I said, it's a accumulation of many years of hard work. Long nights, design, testing, and retesting, and training, and preparing. I mean, it's in a way. Looking forward for a successful launch, because this is just the beginning, right? Once we launch, we have total different things that's going to start happening. We're going to go through the whole cruise phase, the 6 month or so. We're going to land, and then we got to start doing some science and so on. So this is just the beginning, even though it took us 8 years or so to get to this point. It's very exciting. I can hardly wait to push the launch button and proceed. So.
During these next few days, is there much that can be done on the rover when it's already integrated into the launch vehicle, or is it just kind of just waiting until launch day now?
Well, it's a process, right? We finished the final integration. We're installing, the power source. We're finishing the closeout activity for the launcher, because it's a whole rocket that there's a whole slew of activity that needs to take place. Mm-hmm. But this is the final stretch. Within 10 days, within a few days. Within a few days of the launch. Actually, we're launching tomorrow, supposedly, right? So you guys will figure it out. No, actually, we're ready to go for it. Just getting through the timeline. There's a specific time when we need to launch. The window opens on the 30th of July. It doesn't mean we have to launch on the 30th of July. We have a few days of opportunity. We've got about 16 days up to the 15th of August or so. So that's when the window opens, and go 2020. So
that's great. That's awesome. Hitching a ride to Mars on the Perseverance rover is the Ingenuity helicopter, which name incidentally was suggested by one of our Ismaili youth from Alabama, Veniza Rupani. I would like to ask Dr. Abid to share with us a little bit more about the helicopter, specifically on its design and testing.
Absolutely, yeah. So the helicopter is indeed a very, very exciting vehicle. This is the first time we're going to have a rotorcraft system on another planet. As you know, Mars environment is very challenging. Getting there and performing what needs to be performed there is very challenging. What you see here in the pictures, you see the helicopter in what we call in the stowed configuration. So you can see it's going to be sitting in the belly of the rover or Perseverance. We're going to also have a cover on it, what we call the debris shield, because what happened is as we land, as we are landing, when we have the Mars landing engine firing, we're going to have a lot of dust and pebbles and all that stuff. So we want to protect the Mars, the helicopter Ingenuity, that way it doesn't get hurt, because it's fairly fragile on what it is, and I'll describe a little bit more on that. So As you can see, it's it's totally folded in, and then after a slew of what we call an egress event where we deploy, it comes down from the bottom of the rover. It's going to end up in the position of what you see in the bottom picture. So you can see the scale of a person. And what's the span of the blades, and what's the size of the rover of the Ingenuity, as you can see in there. One of the things is, I say, why the blades are so big, and the helicopter is so small, and so on and so forth. One of the things that is very challenging is that the Mars atmosphere is a very thin atmosphere. It's about 7 torr. That's the surface of on Earth. The surface of the ocean is roughly about 760 torr, give and take. So it's about 1/100th of the density of the atmosphere on Earth. So we know how to fly helicopters on Earth, but they don't spin as high as we're going to be spinning, for example, Perseverance, Ingenuity. So the other challenge that we're going to have is the temperature. This is a very cold environment. We're as cold as minus 90 degrees Celsius. That's very cold. So the only one advantage that we have going to Mars is that the gravity is 1/3 of Mars. So that's probably the only advantage that kind of help the overall, flying objects. But in order to get that, so we need to have a light helicopter. We need to have the span of the blades, fairly large. It's about 4 foot long. It's 4 carbon fiber blades that are very light, So we want to do that. The other thing is we're going to make sure that it spins high rates, about 2,500 RPM. A typical helicopter, similar, it's about 300 RPM. So it needs a factor of 8 or so, higher to be able to get enough lift and get the couple pound, roughly, a few pounds of helicopter mass. So that's in an essence what comes in. Now, once you build it, that's one thing, but you got to test it. You got to make sure that it's going to do what it's supposed to do. So we had to put it, for instance, in what we call a 25-foot chamber at JPL. It's big chambers. We get the right parameters, the right atmospheric density, the right temperature as well, cold, and then spin it and making sure that it can actually lift. It goes, be able to sustain its weight and so forth. And then after that, making sure that we'll be able to hover, steadily. There's a lot of tuning that goes into the controls of the helicopter. One other thing that is also very challenging is that when we perform the flight, it's a short flight, it's about 90 seconds or so. We don't have the ground in the loop. So everything is done autonomously. So for that duration, so we said, all we need to say is, we'll just go ahead and fly, and we tell it, okay, fly for this duration and how long, etc. But it's going to execute everything by itself. If you guys are familiar, when you play with a drone, you're always watching where the drone is going and how it's landing, and being hyper vigilant, and you still most likely crash it. So imagine doing all of that, and on Mars, millions of miles away, and autonomously. So it's a really exciting helicopter that's going to be followed dearly throughout the whole campaign. So we're looking for the first flight early on when we land, and we've got a few more opportunities after that. One of the things is that will be kind of limiting from, how many times can we do, is that the communication, in order to communicate to Earth, we need to communicate from the helicopter to Perseverance, and Perseverance to downstream. So that part also will be interesting to watch and follow, and making sure that the helicopter is doing what it's supposed to do, and so very excited about that.
I can only imagine how satisfying it's going to be seeing it flying next to the rover itself. Images of it flying there.
Yep.
I'm happy to share that we have Veniza Rupani with us today. Veniza, welcome and congratulations. Ingenuity, the name you suggested, was the name for the helicopter. Before we jump into the question you would like to ask Drs. Twu and Abid, can you share with us very quickly why you chose the name Ingenuity?
Yeah, so the first thing I thought about was the name of the previous rover, Curiosity, and how it answered the question of why people want to explore Mars. It's because by nature we're curious people. So I thought if that answered the question why, I wanted to answer the question how. How is it possible that we can do something as incredible as do science on another world. So I thought, what one quality best encompasses the intelligence, creativity, and the willingness to try new ideas it takes to get that done. And I thought ingenuity represented all of that best.
That sounds awesome. That sounds great. Venice, I think you have a question for Doctors Twu and Abid.
Yeah, so my question is, what part of your jobs do you guys enjoy the most?
You want to take a... Go ahead.
Yeah, I can go ahead and get started on that. I mean, personally for me, I think searching for life outside of Earth is very, very cool, definitely. But my favorite part of the job is actually just seeing how the work that we do impacts people around the world. That's actually the most rewarding thing, right? I mean, a lot of the questions here that we're trying to answer with these missions are really deeply rooted questions that people have been asking since ancient times, right? What's out there? Are we alone? People have been asking this for, millennia. And these are also the types of questions that everyone can also relate to, right? No matter what your background or culture, where you live, and what you do for a living, and so on. Everyone can appreciate these kinds of questions and the desire to find answers to them. And so whenever we go to Mars, I feel like we're, in a sense, carrying the hopes of everyone on the planet along with us. And whenever we make a discovery, we're doing it on behalf of everyone. And when we find something, everyone celebrates around the world. And on top of that, just I think seeing us pursue such ambitious goals, such as sending a rover to Mars and looking for life and so on, I think it also helps inspire people as well, right? It gives them hope, and it makes them also more inclined to also think big and pursue their own dreams, whatever that might be.
Yeah. From my perspective, I just want to quickly for Rupani, just want to congratulate you again on that, and just want to make sure that everybody knows that, and knowingly, she wrote, you wrote in your essay something really cool, which is you stated something like, are not just a product of pure determination, they are a combination of human perseverance and ingenuity. So without even knowing that perseverance, you already kind of stated that in your essay. That was fantastic. That was really cool. Nice, great job. As far as to answer your question, yeah. So listen, we're working on the most advanced, complex, beautiful vehicle ever to land on Mars, and this is really, it requires a lot of cutting edge technology, diligence, challenges, something that thrives on it. Once you see it, all put together and all heading where it's heading, it's extremely fulfilling. Now, in order to do that, you need a phenomenal team to work with and all that. So, that's part of my job is the team I'm working with and for and so on. It's outstanding. You got very talented and smart people that are all working for the same goal. Kind of answering questions and try to get to this. To final product that you're going to be seeing, soon on the surface of Mars. And from my perspective, there's one extra specific thing is part of just my daily job, is that the best part of my day, if telling me, you had a good day, I would say, what, someone came to my office or called me and told me, hey, we have a problem, we found this issue, we have a challenge, what to do next. And from my perspective, I'll be like, yes, today I'm going to learn something new. Something new is going to come. I'm going to learn something new, and that's something that is recurring all the time. So I hope, that's a little bit what's going on. So it's very exciting, and looking forward to continue years and decades. So in it.
Thank you so much, Veniza, for joining us, and congratulations again. So I kind of wanted to build off some of the points we had talked about before. Today, we live in a world where it seems that there are growing inequities between the rich and the poor, between developing and developed countries, if I may use that term loosely. From my understanding, the rover involves some very complicated technology, and it would be great to better understand how NASA technology is able to benefit all countries, as Dr. Twu just mentioned.
Okay, of course, yeah, I can go ahead and take that question. NASA's technology sort of benefits all countries around the world I'd classify that in sort of three separate ways here. The first, the most direct way, the most direct path is through what we call spin-offs here at NASA. So there are actually thousands of examples of technology and research that we develop for space missions, but we find out later on they actually have a direct application here on Earth as well. And so things, for example, like the ear thermometer, if you ever go to the doctors and rather than taking temperature through your mouth, they put this thing in your ear and it takes your temperature in a couple seconds. That's developed using technology that was developed in part by NASA. Things like the cochlear implant. They're ear implants to help people hear who don't benefit from hearing aids. Scratch-resistant lenses that you have in sunglasses and goggles and safety masks nowadays. Aircraft anti-icing systems, right? And most importantly, the CMOS image sensors. So these are the sensors that are actually in your digital cameras and smartphones that we carry around with us, right? A lot of NASA technology went into creating that sensor. So when you look around you, even though a lot of NASA's missions focus on space, we actually have a lot of technology that benefits almost every aspect of our lives. So that's what I categorize as sort of the most direct path, right? And then indirectly, a little more indirectly is that, in addition to studying space, we're also studying the Earth as well. There's a lot of NASA missions that are Earth orbiters and study every different aspects of the Earth and things such as the early warning systems for natural disasters and so on. A lot of the things, the more that we learn about the planet as a whole, the more we're able to acquire the knowledge and figure out how we can help everyone around the planet, in all countries. And finally, I think a lot of the work that we do here on NASA, it is really, really cool, and it is really, really inspiring. And so one of the benefits here that could benefit all countries is that seeing that we are launching something to Mars and looking for life, will help inspire the next generation of kids and students to become interested in STEM, right? In science, technology, engineering, and mathematics. Maybe they might not necessarily want to work in space or work on NASA or something, but they're going to see, wow, this is something that's really cool. I might want to look into this a little bit more. Maybe I want to take these subjects a little more seriously in school or something like that. So, so that's how I feel like NASA sort of benefits all countries.
That's great. Kind of building upon that question as well, either one of you guys can answer this question. Do you guys believe that STEM education can address issues of inequity?
So it's an interesting question. So, but in my personal opinion, really, so since STEM education is really crucial for critical thinking, building experience, having a hands-on experience to be able to, doing that, chemistry lab or robotics or something, and trying to do some problem solving in real time, how to solve various problems, that definitely builds a lot of great brain cells, and kind of allow students who have access to this kind of type of education, STEM and general education, will be much better positioned, for subsequent opportunities, or just in general, better opportunity for the job market, for what they want to do later, what they can do, what they should do, etc. So it is definitely an opening for what comes up next, in the in students' education. So very important to spread that. Very important to have STEM education all over whenever possible. It is funding constrained. It's not cheap. You gotta still have a lab. You gotta still have the computers. You gotta still have some of the resources, and hopefully that everywhere we have this type of education, at least. Even some of the students, they're like, I don't want to do science. Science is too complicated. But at least trying it, See, maybe they might like it. They might hate it too. So, but it's a try. There's something like this that's doable, explainable. You can answer some question that you may not know that you can answer. Really giving confidence for students that they can do much more than expand their capability. So, yep.
Great. And thank you guys at JPL for always inspiring the next generation. I think that's fantastic that, so many young people are growing up watching what you guys do and are inspired to do that every single day. Suppose that we go further into space, the eventual goal for many humans is to reach those destinations. How close do you think we are to that reality? And what kind of work is being done at NASA right now to prepare for our next chapter in space travel?
Okay, well, I can take the first part of that question here.
Okay.
I think that NASA is within probably two decades or so of being able to land humans on Mars for the first time. So what that means here for a lot of the students watching the audience is, take your schoolwork seriously. If you work hard with perseverance and ingenuity, one day you could actually be the first person in history to set foot on Mars. So, as for what NASA is doing right now, I'll hand it over to Dr. Abid.
Right. So, thank you. So, what there are multiple building blocks, to get a human in space. It's we're able successfully to send a human to around Earth or to the moon and whatnot. The next step is Mars. It's more challenging. It's not a trivial trip. There's the duration, there's the environment, there's getting stuff to breathe. There's a lot of things that needs to go right, and not only right, we're not able to be good at it. We know how to do it. Okay. Cost of launching, the heavier it is, the more costly it is. So try to find ideas and technology, a little bit like what I described MOXIE, things like that kind of technology is critical to success to be able to be able to send human safely and return them safely as well, than sending one-way trip. While some might choose to do that, I think a lot will like to come back home to tell their experience. So, but anyway, so the idea, in order to, sending safely, landing, and bringing back, it's a very challenging task. So the elements such as, how to rendezvous run Mars and come back, MOXIE-like instruments. So that will continue for a few years. There's the trip to the moon, learning a little bit more and building upon our experience that we have. That's kind of step toward heading to the next step for Mars. So there's a lot of building blocks that are in the making that will allow us to go where we need to and so on. So on top of that, there's we need a rocket that can launch a human all the way to Mars. The heavier it is, the more energy you need, the bigger the rocket you need. So the Artemis project, that can come along to help out with all of that. So those are all the constructs that NASA is actively working and getting us to where we need to. So it's a beautiful journey. It's going to take us a while, but we are definitely getting closer and closer. Hopefully I will witness that before I go.
Thank you guys for those responses. I want to pivot the conversation and turn our attention to your guys' personal stories. Can each of you tell us a little bit more about yourselves, where you grew up, and how you decided to pursue the career that you have chosen? And what are some of the challenges you encountered along the way?
Okay, yeah, I can go ahead and answer that. So personally, I grew up in Gaithersburg, Maryland, which is about 25 miles away from Washington, D.C. And as a kid, I was always really fascinated with the idea of just space and adventure, exploration, a lot of these things that a typical kid would be into. And so one thing that really impacted me was I'd watch a lot of movies on TV with my dad, and a lot of the science fiction movies like Contact and Close Encounters with the Third Kind, humans encountering aliens for the first time, they had a huge impact on me when I was a kid. And yeah. I remember I used to play basketball as a kid, and I'd walk home in the evenings, and I'd walk as slow as possible with my head just sort of held up high, looking at the sky and just being amazed at how grand, how big and open the sky was, and just wondering a lot of the questions like, okay, what's out there? Are we alone, right? What kind of mysteries are waiting to be discovered? I found myself doing that a lot as a kid. And so you can imagine, because of that, it's sort of only natural that I, eventually grew up to work at NASA. I essentially get to live out my childhood dreams every day. In terms of challenges now, I think one challenge that I had was really a late exposure to STEM in my education. I didn't really come from a high-tech background. I wasn't one of the kids who sort of tinkered with electronics growing up, or did robotics competitions or science fairs. That I didn't really have any of that. My parents were first-generation immigrants who worked in the restaurant and service industry, and so that was sort of the circle that I grew up around in. And because of that, I wasn't really exposed to STEM career options or even role models in STEM growing up. If you asked me back in high school, I would never ever have imagined that I'd be working in a STEM field, let alone NASA, as an adult. And I didn't even get exposed to engineering until I was in college. Now, the problem here wasn't really sort of lack of interest in STEM. It was more of just not really understanding how it related to me and why it mattered. Right. I mean, I knew people. I knew that, okay, yes, some people out there worked at NASA. No idea who they were, but I knew people must have worked at NASA. But I really didn't know, okay, how did they get there? What kind of paths did they take? And whether that was even possible for someone like me. And in high school, I learned math, but like everyone else, we had to do math and so on. But I never really internalized, okay, why was I doing this math? Instead, it was all just more of math for the sake of math. You get a problem, you do the computation, you turn in, you get a grade, okay, you get more problems. It was more like that for me. I didn't really have that insight when I was younger. And so in my second semester of college, actually, when I took physics for the first time, that was when sort of everything came together, and it was really a life-changing experience for me. I pretty much realized that, okay, almost everything that happens, big or small in our everyday lives, in the physical world, can be understood and predicted by science, right? And math is something that you need. Math is essentially the language that you use to describe the science. And once you understand how all this stuff works, you can then use engineering. Engineering is essentially how do you use this knowledge to our advantage? How do you manipulate all these things that are happening around us to take advantage of it, make our lives better, and develop new technology? All of that sort of came together for me for the first time, in my second semester of college, and that was a life-changing experience for me. So, for the first time, I actually understood, okay, this is why I'm learning all this stuff. Not only that, but also if I take STEM education seriously, it would actually open doors to all these opportunities and careers that I never even thought would be possible for someone like me. So that was a really, really big deal, and really just a really impactful sort of period of my life. And that's one thing I really wanted people to take away from my story as well, which is that, no matter what your background, even if you are in high school or college and, you're watching this and you haven't really done much STEM in your past, right? If you have the interest and you're willing to work for it, it's never too late to start. And I encourage everyone to follow their dreams. So that's my story.
I think that's a great message. I think that's great.
Awesome message. So Leslie, I was born and raised in Sfax, a city in Tunisia. So Tunisia is North Africa. Some people confuse it with Indonesia and whatnot, but no, this is North Africa. Anyway, so I've been always fascinated by engineering, just in general. And I have an affinity more for math. I was better in math than other things like history and geography, but that's a separate story. So anyway, I somehow had better grade in that than anything else. So, but what happened is in 1986, there was the tragedy of the Challenger disaster. As some of you, probably not even born. I was young then, but I witnessed that in real time, and that's where we lost life astronauts. And to be honest with you, it really affected me a lot. And basically, the message was that, I need to go and figure out how to work for NASA or associate, and making sure that this kind of accident will never happen again. Basically, don't happen again. Minimize those. That's kind of thing. So it's kind of started kind of interestingly from called. An incident than anything else. And so that's what got me into space even more and more fascinated. I said, I want to be, solving problems, solving whatever challenges comes about, to be able to resolve, making sure that we can do cool science, cool engineering safely and whatnot. So that, in a way, rode through me throughout my career. So I basically from Tunisia went to France, did my master degree in France, and then moved to the US here and completed my PhD. And so throughout that there was a lot of challenges, technical or others, call it educational or whatnot, that had to overcome. And really, the important thing is I did not lose focus. The focus for me was, at a certain point, I want to work for such an agency. I want to work for an agency that sends spaceship, work on spaceships and landing robots all over the planets and the universe and so on. So, and that's a little bit where where I am today. The kind of focus and persevering, to get where we need to. The one message that is interesting, kind of follow up a little bit, Dr. Twu, about what he said with regard to about the background and what you've seen and how you live through and all this stuff, is that it really doesn't matter from where you are, what's your color, what's your gender, and what else, especially in this industry where I'm at, for instance, at JPL, we've got all kind of people from various backgrounds. And really what matters at the end of the day is what you've got in your brain. What's your willingness? How do you want to work with a team? How well you can work with a team? What can you bring to the table? And that's a really important thing from my perspective. I've got multiple Tunisian fellow that, some of this like, there's no way you can make it somewhere somehow because you're from Tunisia, you're from some whatever country, whatever background is. The great thing is that this really is not non-issue with regard to, STEM education here is one way of overcoming some of those differences. Also background and what you've done, what you accomplished, and how you led to where you need to be. So that's been an interesting journey. Very proud of it and happy with it, and happy to share it with some, mentoring some of the other, fellow, whether it's from Tunisia or other countries, or, within the US to show that, we can really get to where we need to be and accomplish what we need to, as long as you put your head and your mind into it. There's no reason not to. So maybe the line is not going to be direct, there's some hurdle here and there, but at the end of the day, you'll be able to accomplish what you need to if you put your mind to it. So that's my little journey.
Thank you guys so much for sharing that with us. I know that we probably have a lot of youth and university students watching. Is there any piece of advice you'd like to give to them, or any messages in specific? I know you guys alluded to that in your guys' personal stories, but is there anything specific to the students that you'd like to say pursuing anything that they're pursuing right now?
Yeah, sure. I have a message. So, my personal philosophy is this, right? You find what you're passionate about and let that guide you in your decisions in life. Okay. And that's something that's very important for me. For me personally, my passion is in space exploration, right? Clearly, right? You could tell, but but not just that. I mean, I can honestly say that, right? I mean, I can honestly say that I feel so grateful every single day that I'm alive to be able to be a part of this mission, to be able to contribute to it however I can. And I'm honestly so excited about just what the future holds, right? The kinds of things that we're going to be discovering in my lifetime. I feel like this is why I'm alive. This is what I'm here for. And there's really nothing else in the world that I'd rather be doing with my life and with my time. Now, for people in the audience, space exploration is my passion. Your passion might be different. It might be in art. It might be in medicine, and whatever it is. I urge you to find out what it is if you don't know already, and pursue it. Because once you have passion, everything else becomes a lot easier. Things like persevering through hardships, or ingenuity, being creative, all those things come a lot easier and come naturally once the passion's there. So I really urge people in the audience to find out what that is, and also along the way to be as true and genuine to yourself as you can, right? I mean, it's important to know that everyone has their own definition of what it means to be successful in life. Okay, your definition of success might be different from your friends or your parents, or even social media, what you currently see in ads and Facebook, so on. What's successful to you is different and is unique to you, and it's okay to be unique. And that's once you find out what your definition of success is, that's how you're really going to be happy in life. So I urge everyone to find out what that is. And that's my message.
Yeah, kind of building on that a little bit, but along those lines. And one thing is that working hard is really important. Getting, like you said, true to yourself. Know what are your affinities, what you want to expand on it, what you're good at it, and when you want to get better at it. Okay. Now, the other thing is having good grades, right? So it's important to have good grades at school. So to facilitate some aspect for things. But in the end of the day, it's not really, if you want to excel and get to the top of that field, whether it's medicine, engineering, or whatever it is, having just good grades is not sufficient. You need to build on that. There's a lot of smart kids, around, and they can do a lot of miracles. But on top of that, one thing that I encourage a lot, students just in general, is just tinkering in your spare time. Tinkering is really important. You can always watch TV, watch movies, watch whatever, things, that can have some benefit. But at the end of the day, if you watch something that can lead you to something productive, find opportunity to perform project, little tiny project, whether it's chemistry or engineering or robots or things like that. It really makes a difference, because then you will know, hey, do I really like to build robots, or do I really like to do this chemistry, mixing stuff or whatever it is, or do I really like, to heal pets or things like that. So finding the time to do that in your spare time, and I can guarantee you, students have a lot of spare time. Okay, so I know just from my kids. So using that time to kind of call it a little more productive in the sense of try to learn something, try to contribute something, it's really useful. This is your time, because the more you position yourself to your future, the better, the easier you get. Not easier from the sense that you will enjoy it better. Nothing better that you do a job that you like versus a job that you don't like, you just have to do it. So the more you position yourself with something like that, the better you'll enjoy it. And to do that is, use your time. You don't need to spend 12 hours playing a video game. Spend 5 hours, fine, okay, but the next 7 hours try to do a little projects or something like that. So anyway, so that's a little bit what I have in mind in general. But yeah, like you said, it's affinity. Not everybody have to do engineering, or not everybody have to do arts. So follow your heart and follow what you like to do, and build upon and yeah.
Thank you both for that advice. I'm sure the students really thank you for that. As a final question, I just wanted to ask you guys, how can the general public watching this follow both the launch and the rover's journey on Mars?
Okay, so actually, if you pull up slide number 5 here, these are some websites that you can check out. The top one, mars.nasa.gov/Mars2020. You can go there and you'll see things like the launch countdown and mission updates, live coverage of live events. That's where everything's going to happen. So I highly encourage everyone to visit that website. Now, for those of you who want to get even a little bit more interactive and participate, if you go to that bottom website, mars.nasa.gov/Mars2020/participate. There's also a lot of fun and educational activities that people at NASA have prepared for people to do at home. You can do things like record your own version of a launch countdown and share it on social media using hashtag #CountdownToMars. There's a fun photo booth that you can do, and there's tons of activities, crafts, and projects that people can work on at home in their spare time. So highly encourage everyone to check out these 2 sites.
Great, thank you so much for sharing. I just want to thank you guys so much for joining the program. It's been a pleasure moderating. Thank you guys for your time. I know you guys must be so busy with the launch being so close. Good luck for the launch, and it's going to go absolutely incredible. I'm sure of it. I just want to turn it back over to Benish.
Dr. Twu, Dr. Abid, thank you for this enlightening and educational session. There are many who view this new world as the knowledge society. I will leave you with the words of His Highness the Aga Khan at the Aga Khan University Convocation in Karachi in 2006, where he said, and I quote, "The knowledge society will confront people everywhere with new challenges and new opportunities," unquote. On behalf of the Ismaili Jamatkhana and Center, thank you for joining.
Thank you for having us.
Thank you.